Hello, thanks, Chris, for the introduction. Hi, everyone. This is Sam here. My full name is Sam Kavala. You can call me Sam, actually. So I'm working as a tech lead. For those who don't know me, this is a short introduction. I'm working as a tech lead as part of the Palo IT. I'm part of the architecture dojo. My passion is towards architecture as a core, actually. And that's what I do. That's a very short introduction. And recently, I had the opportunity to do my own learning on clean architecture. I mean, it was very recent, maybe a month or two. I just had someone saying, Sam, is anyone? Okay. Okay, I'll just move ahead. So yeah, so I thought let me share my experiences and my learnings with to a wider audience. So that's why we are here actually. So today the agenda is going to be we are going to learn what is clean architecture, and we are also going to look into the various modern architecture styles that are available in the market today. And we're also going to discuss about specifically on what is domain-centric architecture and why it is important actually. And we're going to discuss about functional organization and the testable architecture as well actually. So these would be the topics. So before I start, is there anyone who want to ask anything, or can I go ahead with the topic? Okay, looks like I can go ahead actually. So let me go to my full screen share. I hope you guys are able to see my screen. Am I right?
Yes, we can see.
Okay, cool. Okay, so to start with, I want to start with a story of a tale of two architects. Okay, so a company actually recruits two architects. Okay, one architect actually practices this classical architecture, and he been given a task, to construct a building. They want to build a new office or maybe a big building, and he been given the task. I need an architecture, a blueprint for this, the new thing I wanted to. So this particular guy who practices classical architecture, practices a traditional architecture practices. He's very passionate. He uses his, cutting edge technology and his favorite tools and techniques. And he also uses elegant design and everything he does, because he knows the moment the requirements came to him, he knows what the solution would look like. So he quickly goes and, does everything, finishes the blueprint and handovers to the, the implementation team basically. So who the construction, right? The workers are the masons who want to build that. So they finally build as per the design plan. Yes, the output is good actually. They were able to build according to whatever the architecture was intending it to do. They were able to do, and the company is happy about his work as well. Now let's look at the other architect. Sorry, let's look at this architect. This architect is also same as the other architect. I mean, in terms of using the cutting edge technology, favorite tools, using of the elegant design. But however, he does two things differently actually as part of his architecture work. So what he does is he goes and talks to the future inhabitants of the system basically. What I mean future inhabitants is basically the users of the systems, the end users basically. The second one is the developers who develop the system, and the users that who maintain the system actually. So there are three different actors. So he goes and have a chats with them, understanding about what those use cases are, what those requirements. Though he got the requirements from a business perspective, he just doesn't want, unlike the other architect, just doesn't want to take those requirements and directly go for a design a blueprint. Rather, he goes and really talks to the people and understand what are those pain points, what it should be, does it. So he basically validates everything what he has. And also what he does is during the implementation time, he again he keeps himself in touch with those guys, try to understand, because definitely whatever you design in the first place might not be, working during the implementation. You might face some challenges. So what he does is he incorporates those, requirements during the implementation time. When he takes the feedback, he again goes and incorporates them as part of his architecture, and then he evolves it, and then again, so it's an iterative process actually. So at the end of the day, again, he has done his job at his best, and it's an elegant work that he has done. So whatever he showcased, the client is very happy actually. Now the question comes is, let's say if you're running this company and if you want to recruit an architect, whom do you prefer? Do you prefer the traditional classical architect, or do you prefer the person who practices clean architecture? So definitely it's clean architecture, right? So we all understand why, because we want to build something that is relevant and usable to all those different actors that I mentioned, the users, the target users, the developers, and the maintenance throughout the life cycle of the project actually. So that's a quick introduction about clean architecture. Now, one of the things what we're going to learn today is about architecture essentialism. What does that mean? So it's a way of designing an architecture in the context of what is essential in the architecture versus what is just a detail. And I see this seems to be, I mean, I'm personally, I'm in practicing architecture for the last, couple of years, like I think like 7 to 8 years actually, right? So I tend to see that we put much emphasis on the details than, what is really essential. We think about too much about, oh, future, I need to build something that works for the next 10 years or 15 years. I mean, those were my learnings when I went through these actually. We should never design our system thinking about those details, and we should only think about what is really essential, what is the complexity that you need to take care now. That is what you need to address actually. So let's not get more confused here. You will be able to understand much better when I go through deeper into the other slides actually. So now let's start with a simple definition. What is a soft architecture? I can't really help with a standard definition. However, we all can agree with some common things that I just detailed over here. So for me, the definition of architecture is definitely an architecture that you do should be at least high level. When I say at least high level, it should be higher level than your code. So don't say that the code that you wrote is architecture, right? Okay. Sorry guys, just give me a second. I'll just get into my kid just came from school. I heard someone speaking. It wasn't, the voice was feeble actually. Someone was talking to me. I'm not sure. Okay, I believe no one was speaking. I'll just move ahead. Guys, am I still audible? I just got myself into a room. Am I still audible?
Yes. Crystal clear.
Okay. Please let me know if the voice is not feeble. It's raining outside. I'm not sure the network actually. Okay, so the second item is about the structure, right? So architecture typically details about the structure of the software, how things are organized in terms of layers and all of that stuff, right? So the next level of view is the layers. Basically, your layers is nothing but the vertical partition of the system, a logical partition, not the physical partition actually. Then the other, if I go a little more deeper then into the layers, it's actually the components, right? Your components of maybe a security component or maybe audit component, whatever those actually, what the final details that you're gonna model actually. Then the architecture also talks about how we wire all of these components. I mean, it depicts basically the relationship between the various components, right? So that's for me a simple definition of what constitutes an architecture in terms of the definition actually. So I'll move on to the next slide. I'm not pausing for question. The reason the content that I have actually takes more than an hour to cover. What I'll do, I'll go through everything. I suggest you guys to take your questions right in a notebook or something. If I'm able to finish the whole thing within an hour, then I will ask. We'll have room for the questions. If not, if I'm not able to answer those questions, please send me those questions to me, and I will able to answer you later. Actually, I hope that works. So now, what we are looking is a pyramid representation of our architecture actually. So it's a similar thing what I just spoke in the earlier slide. So basically what you depict is at a high level what the system is, and the subsystem, the layers, the components and classes. But if you look at the pyramid perspective, on the top, it's not very detailed, right? It's very abstract level. But as the pyramid that you goes down, it's going to elaborate more. The class, data, methods, it's going to be much more detailed, right? But generally, architecture focus actually limits itself to a level like, until components. And anything that is classes or data methods is more of, a low level design is what I consider actually. Okay, I'll move on to the next slide. Now, I just want to use this, picture to illustrate, what's a messy and a clean architecture. So what we see over here is the left side is a spaghetti, a bowl of spaghetti, and the right one is the lasagna. And the left one, actually, if you see, it's all the spaghetti is just like, it's like wired, right? It's not very clear. I assume that if I want to take a string, a spaghetti string out of this whole spaghetti, you're not sure. Either you might be able to pull, that's a probability, or it might, cut. Or let's say if you want to insert a spaghetti, let's assume if you relate this to your architecture that you built, if you want to introduce a new string into that, it's impossible, right? And it's very delicate actually. But if you see the one which is on the right, it's very beautiful. The presentation is very beautiful. It's layered, and if you want to have a slice, you can perfectly slice it and see the layers inside it actually. So now let's look at, I just used these pictures for easy illustration, and we can relate to that in terms of what's a bad architecture and a good architecture actually. So for me, a bad architecture is to deal with a complexity that is considered to be accidental complexity than necessary complexity. And we people, tend to do, most of the time we don't realize it, but we just try to overcomplicate the design of the systems, and you might not be able to think now, but over the time the complexity increases and the system becomes very rigid, and any change that you want to introduce have implications with respect to your costs or because of this accidental complexity. So make sure the complexity, I'm not saying that you eliminate complexity. You will have a complexity always there with respect to the size of the system that you build, but make sure that complexity is always the necessary complexity than accidental complexity actually. And the other characteristics that I want to talk is about incoherent. Sometimes when you design your artifacts or the elements part of the architecture, make sure that they are relatable, they're able to talk to each other. Don't just design something very specific that doesn't align with the other artifacts of the whole system actually. So then if you identify yourself, if you find yourself something that is not very relevant and only working for a specific thing, then this characteristic highlights actually it's incoherent for me. And architecture, if your architecture is rigid, it doesn't evolve all the time, because evolving architecture is a very important aspect, because you can't develop a system that works for next 20 years because the market keeps changing, the technology trends changes, the business requirement changes. And if you think to build something just thinking that it works for 20 years, definitely you will fail actually. And so that's why your architecture something that you build has to be should be available, whether it's technology or business, or whatever the requirement is actually. Another thing is it should not be brittle, right? Like the spaghetti code that I explained here, I'm sure that if I try to pull out a string of spaghetti out of this whole spaghetti, it's going to break actually. So, and often it happens, why you see that the code breaks is because it could be lack of testing, right? You try to introduce a feature into the system, and because of the lack of testing, you try to you do a manual testing or something and move the system to the production, and you see something is breaking elsewhere because you don't have complete test coverage over there actually. So eventually all of these implications will lead to an unmaintainable software, right? That's what. So that's what the bad architecture for me from from these various characteristics that if I want to speak to. Now let's see what's a good architecture. Definitely is the opposite of what we just spoke, right? The good architecture is always simple, and it will only have the necessary complexity. and it's easy, understandable. And if somebody asks you, hey, why is this artifact? And you should not be finding reasons to explain. You should be able to easily explain, oh, this is for this particular reason, right? And it should be flexible, and you should, which means you should be able to evolve with the future requirements. And it should be testable, and even all this obviously will lead to a more maintainable software throughout the life cycle of the project actually. Okay, now we talk about what is a good architecture and a bad architecture, right? Now, what is a clean architecture? I kind of given an intro in the beginning of this session. Now, the clean architecture is about, it's something been built based on the philosophy of architecture essentialism. I think you guys can read what is architecture essentialism. Its main focus is basically you put something into architecture what is really essential. When I say essential, maybe let's say you might tend to build a system that might last for couple of years. Let's take a banking software, for example, that you build, and banking industry doesn't change that dynamically, right? I mean, it has a slower phase when compared to the other, like, e-commerce platforms or any other domains that you take, they drastically change. And the adoption of the architecture here is like, would vary, depends upon the domain that you choose. Now, what is architectural essentialism is basically try to put what makes sense for a particular period of time, maybe 2 years of time, what it makes 3 years. But don't make sure that it is not rigid, right? Again, it should evolve all the time. So take into consideration your extension points or exit points or the generalization that you want to do actually. So the emphasis was, what's here is about, you're gonna put what is really essential based on the use cases, business use cases, are the requirements that have been given by those inhabitants. You only tend to build your architecture relevant to what has been put there, not beyond that, not less than that actually. Okay, now architecture should eliminate the implementation details. I will explain what is these implementation details in the further slides actually. Okay. Now, I already spoke about who are the inhabitants, right? The inhabitants throughout the life cycle of project is the users of the system, actual the business users, right? The end users, then the developers building the systems, and the developer maintaining the systems. Generally, if I take the life cycle of a project, initially the developers are into the picture only in the initial phases, right? That's where, like, if I take 100% as a project life cycle, and maybe 30% of the time is where you build your whole system, then 60% of the time you tend to maintain it actually. And the later set of users are more, it's in terms of the users of the system and the developers who maintain the systems actually. Now, when you design your architecture, a clean architecture specifically says that you should never design architecture specifically for architects and not for missions. And what does that mean actually? And we tend to see this kind of, like I myself tend to do, and many people could relate these in your own experiences actually. When a requirement comes on, and we have this tendency to, I want to choose this best framework, best technology choices, and mostly, and people tend to put their resumes because, oh, I have this opportunity to learn something out of this project, and I tend to put there and try to learn. I'm not saying it's a bad thing, but what happens is, what is the prime importance in this case? Is it your preferences, your wishes that you want to put in the first place to build the architecture, or is it the inhabitants, importance of the inhabitants, what is really required in order to fulfill those use cases, business use cases actually? So that's what clean architecture says: never build for the architect, and build for primarily for the inhabitants, and later for anyone. It could be architect or mission. Now, what is mission actually? So when it comes to the mission, the infrastructure is basically, we tend to over optimize our software at the very early stages, and people have this tendency, the code that I write needs to be very perfect, and try to save my CPU time, try to save my memory. I won't say it's a bad thing. Yes, it is important, but the focus becomes more of these secondary aspects than the primary aspects, which is the business use cases. And people tend to give least preference or lesser preference for the business case that you need to build, and you build a system that is not really usable but would be performing very good. And why it's a secondary concern for mission, and considering the current the state that we are in, because in the olden days, infrastructure used to be a bigger concern. For example, if you're building something on a mainframe systems, it used to be a bigger concern because, for example, my personal experience, even today, at bank, I work with some of the mainframe systems. We recently built something that is a cryptographic operation that was, spiking a CPU post implementation. It was spiking the usage to 60% higher than what it was using, and people are worried, hey, what's happening? And it becomes a cost concern for us because the mainframes eats up the money based on the MIPS. So we don't have a choice. We have to eliminate this overhead out of the system too, in another system, external, doing it outside actually. So, but however, with considering the cloud technology that is in space, the infrastructure cost has become quite negligible. It's no longer, maintaining your own on-prem infrastructure that you need to invest a lot of money. So that's why the optimization at the code level is still a secondary concern, that which doesn't mean you have to eliminate it. It's of the second importance, which you need to do at the end, but not but your prime importance should be on the the inhabitants of the the use cases and the mental models of these inhabitants basically. Donald Kunert says actually the root of all evil in software development is like if you try to over optimize at the very early stages. So if any of you, including me, if you have this thought process of, okay, I'm trying to over engineer, over optimize the things that I'm doing, so try not to have that thought process. Actually, to keep yourself away from that, and use your best judgment basically. Okay, so I'll move to the next one. Now, the question is, why should I invest really in the clean architecture? Yes, definitely. The first thing comes into our mind is definitely it's a cost benefit argument, right? And we as an architect need to ensure that we are minimizing the cost, right? That's the goal of the architect, obviously, and maximize benefit. The benefit is in terms of your business value that you generate out of the the product that you're going to develop actually, and eventually it results in the maximizing of the return on investment actually. Now, how does clean architecture actually do this, right? So it's a repetition again. Like I said, our first emphasis should be focusing on the only building of the essential things which are needed by these primary inhabitants. And you basically build a system that actually mirrors the use cases and the mental models of the those business requirements, and we embed them into the architecture as well as into the code actually. And we only have to build what is necessary and when is necessary. You see, you don't build everything in the beginning. You build in an incremental manner. When something is required at a later phase, in the future state, you build at that time. Don't build it now. So, and try to avoid accidental complexity and unnecessary features and premature optimizations basically. So as part of every project life cycles, there is a phase that you try to optimize. You do a performance testing, all of that. That is there actually. So we can take it during that time. Okay, have a pre understanding. I'm not saying you completely eliminate all the picture. But use your best judgment. Okay, so eventually what happens when you do all of these things, you're going to build something that is you're going to maintain it for a longer time. And it's an interesting thought that came into my mind. I'm not sure how many of you really think about these actually. If I ask people like, what is the cost of a project, and many of the people think the cost is only the cost to develop the project. No, it's not actually. The cost of project is basically the cost that is required during the entire life cycle of the project. That means your maintenance and development, everything all together. And interestingly, what happens is most of the time, it's not most of the time, it's all the time, your cost actually, if I take 100% as a cost scale, your cost, 60% of the cost is for the maintenance, and it only requires 30% cost to develop your system. So if you develop an efficient system, eventually you're going to reduce the cost. The 60% of the cost you're going to reduce. But if you quickly develop something, then okay, my job is done. If you've done something, eventually you're going to burn up. You might think that I saved the cost during the development time. Eventually, during the maintenance phase, you're going to bump up the cost, and you're going to build something unmaintainable, and it's going to cost a lot for the companies to add any features or maintaining the system basically. So. Okay, so before I move on, I'll just take a slight pause. I mean, if there is any, burning questions I'd like to answer. Okay, looks like all good. Everybody is able to understand. I can't see people. Let me see.
Hi, Sam. Sorry, I actually posted a question in the chat just now. Can you share an example of accidental complexity?
Second. Okay, I missed the chart actually. Okay, can you share an example of accidental complexity? Unfortunately, okay. Good question. Accidental complexity. I give my own personal example. We were building a couple of years ago a platform, actually a banking platform, and we were thinking that we want to build something, that meets the the next 10 years of roadmap of requirements. We want to be top platform in the market. And what happened, the group of people that we were working with had a little or less experience with respect to the domain, but they were very good technically. They were very good actually. And what happened, we had a mix of people. Some of them are product experts with the technical background, and some of them completely new actually. But however, there was a more decision of power being given to this new architect division. But they put much of their emphasis on the technical aspect. They want to build something very shiny, a platform with a workflow management, with very complicated orchestration of the flows actually. But actually the business doesn't require all of that actually, and it doesn't require on first day or maybe for the first year. And we were thinking too much, and most of the time the feedback came was, hey, you're trying to shoot to the sky, you're trying to build something like a spacecraft or something, right, which is not essential. And what happened was, I mean, some of the participants really care for those feedbacks, and we went ahead and we built something on the platform. At some point of time, after 6 months of effort, we have built something, and we don't know what it is, and it became too complex to evolve from there. And what the end was like, either we had to throw off whatever we had done and again start simple actually. So what I'm trying to tell is, you try to overthink something and that is not relevant to with respect to the use cases, the requirements, and you just want to, you have a kind of understanding or thinking that okay, it might be required at some point of time, and you try to bring in that complexity in the picture, and that complexity becomes turns into your rigid state that you can't, and because of that complexity, any change that you want to introduce into the system eventually gonna cost you more actually. End of the day, it's again cost, right? How easy it's ease of implementation and the cost of the two major factors that's gonna imply basically. I hope I answered your question.
Yes, thanks, Sam.
Okay, welcome. Okay, now I'll move to the next slide. Let me open this comment section just in case, because I'm missing. Okay, so, okay, one of the things very important to the being an architect is making the right decision, right? And people tend to have this, we try to read some of the principles and practices, and we tend to use them as rules or policies actually, but that's something very bad actually, because all these principles or practices are more of a guiding rule. I mean, guiding actually. They are not rules. Never make, I mean, these principles or practice stop you from doing something actually. And that's why for an architect, it's always the decision. If you're going to approach an architect, say there's whether something is right or not, and he always says that, well, it depends upon, right? That's what we say. We never say, okay, as per this principle and practice, this is right, you're saying, because something is right in a particular context, might not be right in a specific context. So that's why in the space of architecture, context is always the king, actually. And the second thing is all decisions are trade-off. I would like to give an example actually with respect to some of my recent experience at bank actually. So at the bank, we have something called standard technology and practices. And what they do is, for them, cost is an important aspect, and bank always want reduce the cost. And you have products from vendors, in-house products, and these products are like legacy. They are 20 years old, 15 years old. And what happens is, like, you as an architecture division, or you as an architect, tend to set these standard practices. Hey, you should not be using, you should not be coming to me for renewal of your Oracle licenses. You should only use open source based databases like Postgres, for future requirements. But the challenge is, because you're using legacy system, you find it difficult. Can I just simply overnight change a database layer? No, it's impossible, right? Changing a database means I need to re-engineer my product so that I certify my product with the new Postgres database. It works in all aspects, and the maturity of the product might have taken in the last 10 of years. And just imagine if I change the database overnight, it's going to break, because the maturity that I reached here is because of the several issues that I raised, that I fixed in the last couple of years, right? And I can't build that that whole time into this small frame, actually. And though we have practices in place, what we do is we tend to do a bit of trade-off. I know it's a legacy system. I know it's risky to to tell you to move to a this support for Postgres database. What I suggest is, why don't you consider a plan of moving all the time, right? Come up with a plan. Let's say next 5 years, you're going to build an alternate platform with a fresh stack and using the Postgres, and eventually migrate all your features to the new platform. So that's the kind of solution we do try to. And what happens, it also helps these them. And if you put strictly, oh, these are the rules, you only have to use Postgres, then it becomes difficult for them, right? So that's what you need to do, actually. And make sure, as an architect, all your decisions that you put in place always aligns with the business goals, actually. And I try to avoid your interim solutions as much as possible. Make sure strategically your long-term, your decisions are aligning with the long-term business goals, actually. And always use your best judgment. Sometimes we tend to do mistakes. I do certain times mistakes. It might not right at certain time, but I realize at late time. But I always use this feedback channel to to improve all the time, actually. So that's about the architecture decisions. Okay, so I will move on to the, let me see if there are any questions. Thanks a lot. Okay, no questions. Okay, now let's move on to the next topic called domain-centric architecture. Okay, so to start with, I would like to start with a simple story, actually. In the past, I mean, maybe 100 years ago, maybe, I'm not sure of the exact period, but at least in the olden days, people used to think that, people used to have this geocentric model as the basis to explain about, how these stars are, move, I mean, how these calendars, everything was based on this geocentric model, actually. What happened was, at a later point of time, and people found that the geocentric model was not efficient, because the geocentric model says that Earth is in the center and everybody is revolving around the Earth, actually. That's what the those days, that was the science we had, and people used to think, people used to believe that was the actual thing that was happening. But later, what happened, Nicholas Copernicus, he came and he brought in this heliocentric model. Actually, he realized, oh, it's not the Earth that is in the center, instead it is the sun which is in the center, and everything is rounding around it, actually. So he changed the model from a geocentric to a heliocentric model, basically. And when he moved that, and everything whatever we were thinking was aligning to this this model, basically. So why I want to use this example over here is, there was a similar shift in thinking was happened over here, because we were in this industry using some of the standard practices that are available there, and we all, most of us people who are experienced, right, if not very recent guys, we were used to these three-tier deep-centric architecture, actually. So if you look at this, the three-tier architecture, so you have the UI at the outer layer, surrounded within inside, you have the business layer, and you have the data access layer. And what actually this depicts is the importance of each layer. So the center is about database, because the database in the center, and it is essential. That's why it is in the center of the architecture. If I say this as an architecture piece and database being the center, that means it gives that's the prime importance, right? And yes, this architecture worked for really many years actually, right? I mean, and this a 3-tier architecture, even some of the legacy systems today works in the fashions, but this architecture has limitations with respect to, the current, needs what we have in the industry is not able to, cope up with that. So that's why we have to have a similar shift in thinking, similar to what Nicholas has mentioned. We had to go to a domain-centric architecture. Okay, if you look at the domain-centric architecture, the domain is in the center, surrounded by your application layer, which takes care of your business logic and the other aspects, and it is surrounded by a thin a layer which is the persistence, presentation, and infrastructure actually. And if you look at the database is not even in the picture of the architecture, right? This is the whole thing. The database doesn't have any preference in the architecture because it is just a detail. So I was talking about right? I mean, in the architecture essentialism, right? I was talking architectural essentialism only focus on the inhabitants and avoids the details. So here, database is just a detail, because when I build an application or when I build an architecture, where I'm storing is just a detail. It could be a database, it could be a file system, or it could be writing it to a S3 bucket in a cloud, right? That is just an implementation details. But what is important for me in the context of architecture is the domain. Oh, I'm handling the customer models, or the with respect to any business domain that I do, or maybe on order management, purchase management, things like those forms my business models. And the advantage is when I eliminate the dependency on the database, my system becomes independent, right? I'm going to explain why it gives an advantage actually. Why this change in perspective? Okay, Uncle Bob, who is the author of the Clean Architecture, and he's been called actually his name is, I think, Martin Richard something, but he's known in the industry as Uncle Bob. Everybody calls him Uncle Bob. Okay, and what Uncle Bob says is, for any architect, right? Let's say if I'm building a house, the important fact that you need to see is whether the house is usable or not, right? I mean, if you look at this picture here, the house, there are two houses that I represent, right? On the top, there is one house, on the bottom, there is one house. Both the houses, they serve the purposes because you would be able to live there. Because what is essential here is the space is essential, because you need the space to live in there. And the usability, you should be able to, close the doors, lock the windows, open the tap. All of these are the essential aspects, and you should be able to use them. But what is details here in this case, architecture is, the material that you use to build this house. For example, it doesn't matter whether you build a wooden house or a brick house that made of brick or a concrete. That is just a detail. We don't care. And the ornamentation is also detailed. Whether I used a shiny metal on the top to look. All those are details. They're not important actually. So what clean architecture says is the domain is essential. Right? In this case, space and usability are the important aspects. In the clean architecture, if I relate to the real world, I mean, in the clean architecture, the domain is very much important, because the domain represents the mental models of the use cases, your requirements, right? So, however, the presentation, right, whether you're going to publish it over a UI channel like a mobile front, or whether it's a desktop application, or it's going to be a fancy UI, that is just a detail actually. That's not the prime importance. I'm not saying it is not important. I'm not saying that we're going to eliminate that. It is still important, but that's of the secondary concern. What is important in the architecture is the domain actually. So I'll just move on to the next slide. Let me see if there are any questions. Okay, no questions. So I hope you guys are able to understand. So I'll move on. So let's look at some of the examples of domain-centric architecture that is available there actually. One of the popular examples are the onion architecture actually. Okay, so if you look at the onion architecture, it is a layered architecture, and if you look, the domain is in the center and surrounded by the domain services and the. If you want to relate to your technical implementation, if you're a Java guy or something, it's basically your entities or represents your domain, right? And you wide up these entities with your repository classes, which is responsible, to load the data from the, database, or could be file system, whatever. That's the other level of abstraction, right? Then the application service layer, where you actually glue both these, domain services and your business logic, basically, right? Or there, and surrounded by a very thin layer called user interfaces, your test, your infrastructure. And if you look at the database, the file, the web service, everything is outside. They're not even part of the architecture. Now, looking at the arrows, if you see, that's very important here. If you look at, because it talks about the dependency. You see, the inner layers are never dependent on the outer layers, but it's the opposite. It's always the outer layers are depending on the inner layers, which means the user interface is depending on the application services is depending on the domain services, and domain services is depending on the domain model. You should always build your architecture or the implementation with respect to these principles and practices. Okay, I mean, onion architecture talks about other things, but my focus for now for this discussion is about the importance of the domain and why the domain is in the center, actually. Okay. So if you look at the arrows, like I said, the dependency is always inward. Okay, keep that thing for now in the moment, for the moment, actually. So I'll go to the next example of the architecture, which is the hexagonal architecture. Hexagonal architecture, I forgot the author name. It's a very popular, quite popular, and especially microservices architecture are built based on hexagonal architecture. It's popular for that, actually. So if you look at the hexagonal architecture, here also, the application, which internally represents the domain, is in the center because it is very important, right? That's your core or kernel I can use. But hexagonal architecture, I mean, it specializes, its importance is more in terms of, a plugin architecture, right? Plugin architecture means ports and adapters. I'm not going to talk about hexagonal, that could be a topic for another session. But what is important here is the domain is in the center. And if you look at third-party dependencies like interfaces, like you see, there is a telephone symbol, like, maybe, sending an SMS or sending an email or talking to the database or talking to a cloud, whatever, external services, they're not even inside the architecture. They are all outside. And the dependency is again, everything is looking towards inside. That is important, actually. See, you see here, the database application has a domain layer. The domain layer has a dependence on the database. However, it's not a real database. You can also mock the database, actually. Okay, that's the importance, actually. Now, now what is the clean architecture? Clean architecture is again a domain-centric architecture, and it's nothing different from the two previous architecture that I spoke. So here in the center of the clean architecture, it is the domain, which is the entities that I spoke, surrounded by the use cases. Your use cases is nothing but your business use cases. Then surrounded by your controllers, and how do you expose them over the gateways, whether it's a REST API, whether it's a a web service gateway, or an MQ messaging gateway, whatever it is, and your how you're going to present it. And later the ports and adapters is still here. And the later outer layer is nothing but which database you connect, which external interface, UI, web, all of those becomes the your last concern, actually. Now, additionally, it also talks about this BCA, boundary control entity architectural pattern, actually. I'm not going to cover this particular aspect in detail here, but what actually BC pattern talks about is, BC pattern talks about what is your controller layer, what are your entities, what are your bounded boundaries, basically. How they all are wired up. Like, for example, if I can give your presentation layer calls your controller, right, form of an API. Then you expose what you're exposing to the outside world is only the controllers, right, for a channel. Then controller in turn calls your the service layer, where you have your business use cases, and the service layer is never exposed directly outside. And then the service layer talks to your repository or the entities internally, actually. So the BC pattern technically, talks about the same concept. Like you can take a look at online. It's more on that. So clean architecture. Additionally, Uncle Bob went and explained how you actually wire up all of these things, basically. Now, so if you see hexagonal, onion, clean, they're all the same. And what is important is, I mean, they have their own specifics, they have their own benefits in terms of, the actual implementation, but that's not the important topic for now. What is important, because in the context we are discussing is about the importance of the domain. If you see, all three architecture has the domain in the center and everything else around. And if you look at the dependency, everything is that the dependency is from outside to inwards. It's not inwards to outside. Nowhere you see anywhere it is inward to outside. And why it is important? Why these guys talking outside? What makes a difference? Why we should build systems like outside to inside rather than inside to outside? It is important because then you can test these layers independently. When you eliminate the dependency, they become independent, and you can test them in isolation. Actually, that is very important. And why I need to do that? Because if tomorrow, if you want to replace a particular layer with something else, it becomes very easy. Because if you build something like having a dependency, a controller directly calling a repository, and repository having a dependency of controller or presentation or something, then they become all interlinked, and you won't be able to segregate, right? We all understand the print is the same design principles actually. Now, so again, so the architecture is, the focus is the domain, creates less coupling, and it helps to build your system using the DDD approach. I'm not sure how many of you are aware of the domain-driven design. Eric Evans has brought this concept of domain-driven design. This topic itself is a very big, it can go for 2-3 hours actually, especially when you build your microservices, complex microservices, people tend to use this domain-driven design approach to build their systems. And I won't be covering that, but at a higher level, what it talks about is how do you design, what is your, how you're gonna decompose your system into multiple services. What is a bounded context? What are value objects? What are entities? All of that actually, how they need to be built, and that's what DDD speaks about. But that's for another discussion. Now, what are the disadvantages of domain-centric actually? I won't say it's really a disadvantage, but there are certain challenges that we need to address. One is there is an initial higher cost. Like I said, whenever you build, you might ask a question. If I'm building a very simple solution, that's the focus of the solution is only gonna work for, maybe 1 year, 2 years, not for a very long time. Do I need to, generalize so much, keeping the domain in the center, all of these things? And do I need to, because building a domain-centric architecture involves a level of complexity because you're trying to generalize certain things, and also it requires a level of maturity for the individuals. If you just get someone out of a college who learns this 3-tier architecture, they would find it difficult to really understand what I need to put in terms of what components should I put in a domain layer, what components I need to put in an application layer. They find it a little difficult. But if they've been guided with an experienced person, they would be able to easily understand. The other part is, again, the BAU, right? The maintenance phase. In the maintenance phase, you'll have the same challenge. Let's say if there is an issue or if there is an enhancement request that is coming, and you build this domain architecture system that is in place, and if you put some fresher and ask him to do, and he might get confused, right? So, I mean, that's the only downside we see. But again, I said you need to ensure there is right documentation so that it helps that person to easily understand. So, basically what I said was it requires more thought, definitely, and people who want to design needs a bit of level of maturity to really understand what I need to put in each layer. How do I segregate actually? And definitely requires a bit higher cost, because in the long term you're gonna save the cost, because it's easy for you to evolve all the time and accommodate future requests easily actually. So that's why domain-centric architecture is important actually.
Okay, because the implementation for Marcoms, right, is that, okay, there has to just be 40%, okay, 40% commenting, right?
I think I'm hearing a voice, guys. I don't know, someone is talking to me. I hear a lady's voice. If not talking to me, please go on mute, okay? Thank you. Okay, so the next thing is the application layer, okay? If you look at the application layer, now this is the modern 4-tier architecture. So you have the presentation layer, you have the application layer, you have the domain layer, and you have the persistence and the infrastructure layer. Now, what I'm trying to highlight in this picture is there are two aspects. One, how the flow is happening. If you look, the flow, the flow is happening from user to presentation layer, presentation to application domain. However, application is able to persistence and infrastructure. And then persistence is talking to database, and the blue lines actually. But if you look at the orange lines, it's not the same. If you see, the persistence has a dependency on the application, the infrastructure is having a dependency on the application layer actually. So we are reversing the, we are trying to invert the dependency over here, right? And many of us, because the principle is the abstraction should never depend on the detail. Rather, the detail should always depend on the abstraction. And many of us, we actually practice this. I mean, if you want to relate, like, for example, if you use the auto-wiring concept or different inversion of control principles today, like I mean, if you are using Spring or any other frameworks which supports this DOI, these are the principles that they exhibit actually. Am I right? So you're going to use an auto wire or maybe wire it through a qualifier. But what happens is the dependencies are wired to those abstraction at runtime, right? So that's what it talks about actually. So you have the persistence layer, you auto wire into your application layer infrastructure. I mean, sometimes you will have more layers depending upon the systems, but at a minimal, this is what a four-tier architecture would look like actually. And the advantage is it is independent, deployable, flexible, and maintainable. Now, if you look at the right side, the cross-cutting concerns, for those who doesn't know what is a cross-cutting concern, cross-cutting concerns are generally these services are whatever you use across all of the projects in the presentation application, all the layers. Examples are audit, logging, right? These are an examples of cross-cutting concern, transaction management, right? These could be some of the examples of cross-cutting concern. And you might want to duplicate these across all the layers. Rather, what you do is you build as a separate project and share across these layers actually. So that's why we call it as a cross-cutting concern. So I'll move on to the next slide. Here is an example which reflects that same four-tier architecture. So there is a sales controller in the presentation layer, and there is a sales command. And here, I'm not sure if people are aware, there is a pattern called CQRS, command query pattern. There's a popular pattern, especially when people do events sourcing all of this kind of architecture, patterns. But I won't be explaining that now. Actually, that's what this depicts. Actually, you have a command class. This command class actually does all this, required use case execution, business logic. What it is having a dependencies to the, abstraction here. It's not to the detail. If you see, it's iDatabase service and iInventory service actually. And create sales command itself is a detail again that has a dependency on iCreate sale command. Now, if you look, iSale command and iCreate sale command, both the abstraction and the details are packaged as part of the same project, but the database service and the inventory service abstractions are only available within the application layer. But the implementations are in a different project, which is the persistence and the infrastructure, right? So it's packaged in a different project. So that's how we design our things actually. So it becomes independent. So when I want to have a different database service, maybe today I'm using relational database. Tomorrow, if I want to switch to a document database, right? Or something else, or a file system database, I can easily switch. My contract remains same actually. Similarly, the cross-cutting concern, you can see there is a date service, which is a common date utility required for this particular piece of functionality. They have the date service and the implementation abstraction because they are two are related there in the same project. However, if you look at the dependency, it's outward, right? Here, create sales command has an outward dependency to the date service actually because it needs the dependency actually. So, yeah. So with that, we discussed about we completed the importance of domain, what is domain service architecture and what is its importance, why it is important actually. So I'll move on to the next topic. I'll just take a pause if any questions, burning questions. Okay, Kevin Lawrence has put command query responsibility separation. Thanks, Kevin. Secures. Okay, looks like no one has any questions. I will move on. Now, functional organization. I mean, why it's very important is basically it's a way how you organize your things, how you organize your classes, components, your artifacts in your systems, namespacing, and it's very important actually. And why it's important, I'll start with this metaphor actually. So if you look at this, the picture on the right side, it's a blueprint, right? The moment you see the picture, you know it's a blueprint of a flat or a building. And if you look, it immediately tells you, oh, the top 2 rooms are bedrooms, and there is a dining room, there is a kitchen, there is a bathroom here, there is an entrance, there is a living room. And immediately what pops into your mind is the use cases. Oh, bedrooms are for, to rest and sleep there, and bathrooms for taking bath, utility space for this. I mean, immediately the use cases comes into picture, into your mind basically, right? And I recently learned this, something called screaming architecture. It's a nice word. I mean, if you guys, Google it, you'll find it actually. It's an interesting word. Whenever you design your architecture, and what it says is it a screaming architecture or not? You can say the screaming architecture always, the moment you see, immediately if you look through, you should be able to scream its intent. Like in this example, when I see, we know it's a blueprint of a building or a flat. Actually, it's screaming its intent, and the users are able to understand what it is actually. But if I use the same example with a different architecture example, here is a table that details some of the things that are required to build that architecture. For example, appliances, cabinets, doors, fixtures, floors. They actually talk about that, but the confusion is, does it really convey the intent? Oh, maybe this could be you might be trying to build something, a cabinet, or it could be building a kitchen alone, or a bathroom, a bedroom alone. It doesn't clearly detail the intent actually. So this is an example of a not screaming architecture. And again, it's a metaphor. I just want to give it as an example actually. Now, why it's important? It's because the screaming architecture specifically talk about how you organize your things, the artifacts, so that it can scream its intent. For example, we all know that in the the traditional practice, many of us still today are accustomed to the practice on the left. We tend to model like MSc, for example. We put all our application models, domain models into the domain package. We put all our controllers into, controller class, views into views. And if there is another layers, we tend to put that, and everything we organize by, categorically we organize them. And you can ask what's wrong with that. I mean, there is nothing wrong, but what happens is, when you do a categorical organization, what happens is over the time, when the size of the project grows, you tend to create hundreds of classes. Then it becomes hard for you to to relate which classes are related. You will lose that. You will lose the value. It doesn't exhibit the business value. But if you organize, what clean architecture says is you need to organize your artifacts or classes or methods or whatever with respect to your use cases. For example, if you see on the right side, customer use cases. If you organize your controller models views as per the use cases, like all customer related controllers models and views into customer products related to customer, everything into that, then it becomes easy for any new developer, like the moment he looks at, oh, these are customer related stuff, these are product refers. So it gives more of a cohesion that is based on functionality rather than categorical. So that's the advantage what clean architecture emphasizes. And is it a hard and fast rule? Can you do 100% doing this? My personal experience is definitely you don't have to do this 100%. You tend to develop or design or organize your artifacts related to business use case in the right side manner, but there could be cross-cutting concerns or technical artifacts or the building blocks that is required. You might not want, you won't be able to do it as a functional cohesion. In that case, you can use a layer, So some part of the classes can still be layer, and majority of the part of them could be in a categorical cohesion. Why the advantage? I can say, let's say I give an example in a Maven bowl. If let's say customer is an artifact, product is an artifact, vendors is an artifact, each having its own versioning, right? It can evolve independently. But if I package everything in the left side pattern in a categorical manner, they all together and I can't independently. Let's say if I want to change customers, it has an impact on others. So in a regression perspective, I need to test again the other functional artifacts as well. That's the disadvantage or downside that I see actually. Okay. So I'll move on to the next slide. This is another example. Similarly, if you see how on the left side, the categorical cohesion versus the functional cohesion, basically. So on the right side, it gives more meaning. It's a dining, set. Basically, you have a fork, a spoon, and the knife. It gives a meaning, right? It's a dining set, basically. Similarly, on the right side, you see controllers, content, model, scripts, views. On the right side, customer products. So if any of you guys are doing a categorical based, organization of the code, try to stop doing that and try to embrace, a functional cohesion approach, basically. That's what I can, recommend. Okay. I'll take a pass on the, we are done with the functional organization. Any questions? Okay, aspect-oriented is an implementation of cross-cutting concerns. Yes. Yeah, it's one way. So Rupesh has written aspect-oriented programming is an implementation of cross-cutting concerns. Yes, it's a way to handle cross-cutting concerns, but it's not the only way, I would say, actually. Yeah. Okay, now testable architecture. Like I said, the architecture that you build, it should be testable. Okay, let's gonna understand. Okay. Now, how is the current state of testing looks like? I mean, we might be experiencing in our day-to-day job, right? Oh, sorry, guys, it's already 1:32. I think I don't have much slides, and it's only a couple of slides. I might need another 10 minutes. I'll quickly wind up. I hope it's still fine. Am I right?
Yep.
Okay, cool. Okay, the current state of the, I'll go a little faster. So the current state of, testing, if you see, people tend to do very little testing because of the reasons. Maybe the architecture is not allowing them to test. Even if they want to write test cases, they are not able to do the right test cases. And what happens eventually, it leads to ineffective testing and inefficient testing. Eventually, at the end, it's an unmaintainable software, right, that you build. And the reasons could be why you are not able to do is people tend to say, I've been not given enough time to write my test cases. And some people say, oh, and it's not my job. It's more of, tester's job to do the testing. Or sometimes you say it's too hard to write the test cases. So the reasons could be any of these, or maybe some other. These are to name few actually. Now, I think there is a lot of noise. Once close the window. Okay. Test-driven development, I think most of you guys might be aware. For those who doesn't know, I mean, test-driven development is a practice that's getting very popular, quite popular these days. And there is a lot of opinions, people about, who wants to adopt, who doesn't want to adopt. But however, clean architecture embraces TDD approach actually. So what happens in a TDD approach is, you actually start writing a failing test case first, rather than writing the actual business logic. You first start writing a failing test case. Then for that failing test case, you actually start to write, the business logic or the code, the service class, whatever you want. Then you try to, pass the failing test with this code that you have written. If it passes, so that means that the test case, when you're writing a failing test case, you consider those, like what we spoke, the use cases, right? In the clean architecture, you try to, let's say I wrote first two use cases. I wrote a couple of failing test case for that, but there is nothing, right? Nothing that you haven't really written the implementation. If you run the test case, what happens? It's going to fail. It keeps failing, right? So now you start to enhance your class by, enriching with the details, and you'll try to pass the test case. So when the test case passes, eventually what happens is, you are sure that all those functionality is covered in terms of those use cases. Now what you do is, again, you will enhance your test case for another set of use cases, and eventually it fails. So it's an iterative model basically. And for TDD, there is another depiction. They call it as a red or a green or a refactor states, right? Red is a failing test. Once it passes, it goes into a green state. Once it passes, again, you will try to refactor the class again. So it's a iterative process actually. So in a clean architecture, TDD is considered as one of the key component. And the advantage is, I mean, today most of us, we would be, I mean, if you honestly ask many developers, hey, would you write test before writing the actual business logic? Many people hesitate because everybody wants to have put the thought process into writing the actual business logic rather than writing the test cases, and that's actually creating a problem. And at the end of the software, we feel lazy, or we become reluctant, or we might even forget what we want to write by the time. And for the sake of doing a test coverage, write something, but that doesn't really add any value. Either you end up in a situation that you won't have the test cases, or you add for the sake of doing a test coverage, you add something but doesn't really bring the business value in terms of those use cases what you want to cover actually. Okay, so in the world of testing, there are different types of test cases, right? Unit test, integration test, component test, service test, UI test. And why they're being tested? They're tested for the purpose of functional testing, acceptance, smoke, exploratory. And how are they being tested? Some of them are automated, some of them are semi-automated, and some of them are manual tests actually. Now, I want to talk about this test automation pyramid. It's part of some book called Agile. I forgot the name actually. I can let you know later. What this test automation pyramid depicts is, it actually talks about 4 types of tests actually. So in the bottom you see it's the unit test, above that service test and the UI test, and outside the pyramid is the manual test actually. So these are the 4 types of tests usually people tend to write or do, right, part of their project development, right? Now if you look at the arrows, the higher you go towards the pyramid on the top, it inflates the cost actually. It's going to high cost high. So the cost of writing manual tests and UI tests, it's going to cost higher than writing service tests or unit tests, right? So that's why most of the time you see people writing more number of unit tests than lesser than that service test and lesser than UI test and manual test actually. So the higher you go, the cost is going to be higher actually. Now, from a clean architecture perspective, what it says is, in the earlier pyramid, if you see, service tests are generally, right, for the business service that you write. And today, the developers' focus is more on, technically evaluating whether my contracts are fulfilling with respect to the functionality, what I'm writing. But the focus is more on the technical technical aspects, fulfilling my tests are running or not. But if I look at the acceptance tests are generally done by during an UAT phase, right? During an UAT phase, you actually test your business functionality, taking those use cases, right? So here, what I'm emphasizing over here is about your test should cover those business use cases. And today, many of us, tend to give this responsibility to, the manual testing teams, right? Where they write their use cases and they do either manual testing or they tend to automate, but that's more out of your, the actual development cycle actually. That's the end of the phase actually. So what clean architecture emphasizes is, and try to get those business use cases, and instead of writing simple service classes, I'm not telling you completely eliminate it, you will have, but try to have these acceptance tests as part of your development phase. Try to build your acceptance. And generally acceptance tests are in business language, right? And there are frameworks like BDD is all about that, we all understand, right? So Cucumber, frameworks like Cucumber helps write at a high level your business cases, and then underlying it's going to execute what are those test cases that you have written actually. So what happens, the advantage is the feedback cycle is quick rather than waiting for go to a UAT phase and get the feedback. Now the feedback becomes, it's faster basically. The moment you develop, you have the feedback, you incorporate those changes into the development phase itself, and when it goes to the real UAT, you see very less bugs, maybe should not be able to cover 100% of use cases as part of the development cycle, but as an architect, as developers, you need to cultivate this interest within the team, to agree upon and to write these acceptance tests as part of the development cycle actually. Okay, now how does it look like? I mean, from a 4-tier architecture perspective. So before we had the presentation, application, domain, persistent, everything. And what happens now, the challenge, okay, it's good. hey, you're asking me to do the acceptance testing during the development phase, but what's the challenges? The challenges is when you do an acceptance testing, you're actually testing a real application by having a dependency with the external interfaces. Could be an SMTP server or talking to an external third-party interface. You all have those dependencies, but in the development environment, you won't have any of that actually. Now, how do you ask me to write acceptance tests? And that's where the advantage over here is. What we do is we try to use, you won't have the real database, but you try to use the in-memory database, and you try to mock the infrastructure service calls and also the cross-cutting concerns. For example, if I'm using an ELK stack, right, for auditing or logging, I'll try to mock all those services that eliminates the external dependency, and I would be able to, I will ensure my application layer and domain layer is completely tested and it's bug-free basically. So that's what it looks like from an acceptance test perspective actually. The right side of the picture. So we also eliminate dependence on user interface. That's what's the whole objective of this whole clean architecture, right? So we should be able to test our layers independently in isolation without having external dependency. So why testable architecture roundup? So definitely it's easier to test and improves design, eliminates the fear, because if you have enough tests in advance, right, your approach itself is test first and development later, ensures all your use cases are covered. Any functionality that you introduce in the future, or any bugs, if you try to fix, these test cases will ensure the system is not broken, so you won't have surprises actually. Okay, however, this approach has a bit of downside. I won't say it's a downside because you need to invest a bit. That's why it's like was a bit of a cost there. Then again, TDD is again a discipline, like I explained, right? It's not something everybody could do, can do naturally in the first day. It takes a bit of all the time. It's a discipline that you need to cultivate, and also it needs an acceptance from the team. Oh, we can do this. I'll just give an example. Let's say you enforce TDD as part of your team to do. But what happens is every developer in the team might not be, showing that same level of interest. What happens? One developer writes more coverage of tests and he ensures all the test cases are covered, all the use cases are covered. But the other lazy developer thinks, oh, I only write 2 or 3. So we have a challenge here, right? So what we need to do is, we need to ensure as a group, as a team, as a squad, that we agree upon this approach, and we ensure that we stick to this process. We strictly do test-driven approach, and it takes some time. But once you're comfortable, you should be able to do it easily. Actually, so that's it, guys. The evolving architecture I want to cover as another topic, but technically, in a way, I just said, right. Like I said, your architecture should be able to evolve over the time in order to meet your future requirements. Not only business, it could be technology aspects, because the technology is not static, right? It keeps changing. So, and the challenges that we see, especially in the industry, is nobody wants to, invest in, the tech debts. There is always a tech debt and there is a business debt, right? And you always get the funding for the business debt, you never get the funding for the tech debt. But as an architect, it's your responsibility to ensure part of the business debt, when you execute, your tech debt is also getting involved. But you are lucky if you get a dedicated budget for technical debt. But most of the time, my personal experience is it's very rare that you see, because the business doesn't really see the value in the tech debt, because it's hidden. They only see the features, right? That's what the outward appearance is actually. So make sure you, being an architect, it's your responsibility, because the business guy is not taking that ownership. You as an architect need to make sure your tech debt is growing. If you see that your tech debt is stagnant, eventually the product is going to collapse and it's going to cost you a hell lot of amount during the maintenance phase actually. So with that, I close this session, guys, and it's Q&A. So if you guys have any questions, please shoot out the questions. I hope I was able to, the session is helpful. Yeah, share your feedback, guys.